So here they all are in their incredible glory. All right, so this equation is ugly, but we're going to be able to make a bunch of it go away. And the reason that we're going to be able to make a bunch of it go away is since we're going to evaluate it at u and v equal to 0, 0, we're just going to make all these plus u's and plus v's everywhere be 0, 0. Okay? Remember, we're evaluating our derivatives at 0, 0. So all of these terms that have the plus u, plus v, the plus u and the plus v go away, and you get something much simpler that looks like this. Now, that still looks kind of ugly, okay, until we start to realize that a lot of this stuff goes away. So first of all, what is e at 0, 0? What is the error I get if I don't slide the thing at all? It's 0. Great. Next, I've got this funny little term here. It says I of xy minus I of xy. What is that? You betcha. 0. Okay? And here it is again. 0. And notice this 0 is the one that's multiplying the second derivative term. And what about down below? Another 0. That's the one that's multiplying the cross derivative term. So when I get rid of all of the stuff that equals 0, my equations become very, very simple, and they look like this. Okay? My main function is 0. My first derivative components are 0. And these components, which go in the matrix, they are just these simple terms here, okay? And you'll notice that the only thing in here is first derivative with respect to x times first derivative with respect to x, first derivative with respect to y times the first derivative with respect to y, and the first derivative with respect to x times the first derivative with respect to y. Say that 7 times fast. There are no second derivatives left. So getting rid of all my erasures, we take that bottom part, we shove that into the top part there, because that's the only thing left that's going to be non-zero, right? Because this is all 0 and this is all 0 because of these zeros. All right? So when we do that, what does our equation look like? It looks like this. All right? So the only thing we have left is that the evaluation of that error function for a small u and small v is approximately, remember it's a Taylor series approximation, is approximately this function. Okay? And remember, no more second derivatives. They've been killed by multiplying by these zeros. We just have the squares of the first derivatives and then the product of the two different derivatives.